Hi, and welcome to Big Data and ArcGIS, an introduction to ArcGIS GeoAnalytics Server. I'm Sarah Ambrose, and I'll be presenting with Noah Slocum. We're both product engineers on the GeoAnalytics team at Esri. First, a quick overview of what we're going to talk about today. The first thing we're going to talk about is what is GeoAnalytics. Some of you may not know, and hopefully we can help answer that. We're going to talk about the differences or why you would want to use GeoAnalytics Server versus GeoAnalytics Desktop. We're going to talk about the tools that we have. We're going to talk about the data that can be used as input and output, as well as the system requirements. We're also going to include demos throughout. So this very first slide shows a bunch of data on the left, as well as us drawing that data on a map on the right. We want to emphasize that every solution starts with a problem. So you probably came here with a problem to solve today. And usually the problem that a lot of people have with GeoAnalytics is, I have a huge amount of data, and how can I make sense of it? So what is GeoAnalytics? GeoAnalytics parallelizes computing to quickly analyze large amounts of vector and tabular data. So vector data being point line polygons, and tabular data, it might not have anything spatial, it's just your features, your attribute table. This isn't raster analysis. There is a similar raster analysis presentation and project where they do parallelized computing for raster analysis. So if that's what you're interested in, I would definitely recommend looking into those sessions. And what this really is GeoAnalytics Server offers a toolbox that is a set of analysis tools that allow you to identify patterns, relationships, anomalies, and incidents in large amounts of data across space and time. Time is really important for big data because often big data is created by accumulating something over time, or maybe it's GPS devices, cell phones, that type of thing. So why would you use GeoAnalytics Server? Maybe your existing tools and workflows aren't processing your data fast enough. So that might be they are taking a few hours or a few days or a few weeks. Fast enough is defined by you. Your data is growing and you need a better way of managing and analyzing it. So maybe you don't know how to ingest that data. Maybe you know that you're going to have really big data soon. So how can you be prepared for that? Or maybe you need to distill your data into something more manageable for use in other analysis. So maybe you have a huge data set. You know that you have something interesting in there, but you don't know where it is or which features you need to pull out and then do further analysis. Or maybe your data has a lot of noise and you want to explore it to bring out what's really important. So GeoAnalytics leverages spatiotemporal analysis to answer questions like the following. And these are just examples. There are many other options and ways you could run the tools and answer different questions, but this is just to give you an idea of questions that these tools might help you answer. So for example, using billions of emergency calls accumulated over the past decade, which counties have the largest number of calls per square mile? Or which stationary pressure sensors in my pipe network have experienced anomalous events in the past 24 hours? And are there hotspots of those events? Or where have my delivery trucks traveled and where is the highest density of unique delivery truck paths? Where do delivery trucks travel the slowest? So GeoAnalytics is actually available through two different products. So what we're talking about today is GeoAnalytics Server, and that's distributed processing across multiple cores and machines with ArcGIS Enterprise. There is also a GeoAnalytics Desktop Tools toolbox in ArcGIS Pro, and that one is available through Pro and it will use the cores on your Pro machine. We have a presentation at Dev Summit, and you can find it online on YouTube for the GeoAnalytics Desktop tools. Myself and Bethany Scott give that one. A lot of the content is very similar because we have the same tools in both, but there's some slight differences in learning about Server. For example, this presentation, we talk about how to set up Enterprise and Server versus GeoAnalytics Desktop. The tools are pretty similar, which will lead me to my next slide about when to use what, as well as we'll have a table that kind of outlines the differences. You could definitely be using both. it's not one or the other, but I think where you start, often it's easiest to start with the desktop tools and move to server. But if you already know that the server is right for you, that might be where you start. So use GeoAnalytics Server when you want to bring big data analysis to your entire organization. So because it's powered by GeoAnalytics Server and it's federated with your portal, that means that many people in your organization could use these tools, and the results would automatically be feature services shared with your portal, and you could share it with anyone in your organization. Versus Pro, where you might be doing local analysis and it's not available to everyone in the organization, it's just on that one machine that has Pro. You can leverage the power of one or multiple server machines, so you can scale up the analysis from 1 to 3 machines. You can connect to external big data storage, so Hive, HDFS, cloud stores, other feature services that you want to use for analysis. And you can also extend using custom analysis. Noah has another presentation with Michael Park, a developer on our team, where they talk about a tool called Run Python Script, which allows you to write your own custom Spark analysis and distribute the analysis on your GeoAnalytics server. So in addition to the tools that we provide, you can write your own analytics as well. And for GeoAnalytics Desktop, you want to process local data faster than before. So you might have files, you might have data in a file geodatabase or an enterprise geodatabase or shapefiles, and that's when you might just want to use GeoAnalytics Desktop. Or if you want to prototype workflows that would be used in GeoAnalytics Server. So say you have a huge workflow and you're not sure if you want to use Server yet, or you know that it will take a very long time to process and you just kind of want to iterate on your analysis, then using Pro would be a great idea to maybe use a subset of the data, try it out in something that you're familiar with, which is Pro and GP tools, and then once you're like, yep, this is the analysis I want to do, let's scale it out, you could use GeoAnalytics Server. Here's a quick table comparing the two, GeoAnalytics Server on the left with the 10.9 release, and then GeoAnalytics Desktop on the right with the Pro 2.7 release. For the input data, that's a big one. Where your data is already will probably help determine what you want to do. If you want to use feature services as input, GeoAnalytics Server is definitely a better bet. Whereas if you were like, oh, actually, I want to use this data in a file geodatabase and it's on my machine that I already run Pro, GeoAnalytics Desktop might be a better bet for you. For the tools, there's more tools currently in GeoAnalytics Server. I think most of the tools in GeoAnalytics Desktop are a subset of the ones in Server. They just don't really make sense to add to Pro versus running in the server. For example, there might already be a tool that performs really well, or it might be a service-based tool like Geocode, where there's no Geocode server to back up the Pro tools. But in general, since this presentation is on GeoAnalytics Server, you do get more tools in Server anyways, in addition to Run Python Script, which allows you to write that custom analysis and distribute it across the server. For the interface, you have a lot of freedom, and there are going to be slides talking about that. So the GeoAnalytics Server tools, you can run them through the web map viewer, but you can also run them through Pro. So the GeoAnalytics Server tools you can run in Pro, and then you also run the GeoAnalytics Desktop tools in Pro, and you can tell the difference based on the toolboxes and the names of the toolboxes. There is a blog post covering this. It was written when they first came out, so I think I'll probably have to update that and make sure that it's clear about the new tools, but it does outline why you would choose one or the other. So GeoAnalytics Server, I mentioned that you can run it in Pro, and here you can see I am doing just that. So this is running against Pro, and that means that, against your GeoAnalytics server. So you're in Pro, you fill out the parameters just like you would, but then the actual analysis is running on your enterprise GeoAnalytics server. So it's not running on that machine, it's sending the information, and that's where it's running. It's running on the server. You can also run it through your portal map viewer. So this has tools that show up. They're very similar to Pro. They're a bit more interactive because they're in the web. Oops, sorry. And then you also have the ArcGIS API for Python. So these can be written in notebooks. You can also use the ArcGIS API for Python in your IDE of choice. And then you can also run tools directly through the REST API. Most people do not do this. I like to do this, but if you wanted to write your own app to call into the tools, you would use the REST API. So that's why this example is here. That leads us nicely into learning about the actual analysis capabilities with GeoAnalytics Server. So we've broken up the tools that we have available into tool sets that will just conceptually help you understand what these tools actually do. I am not going to go into detail of every tool. I think in the last slide we said we had 28 of them, so there is no way I'm going to go through all of those details. If you're interested in one of those tools, there's documentation available, and if you still need more questions, we'll provide our email address at the end that you can always contact us and ask. GeoNet is also a great resource for asking those types of questions. There's a great community with people that will help you answer which tools you're interested in. So the first tool set, and these are not in any order, basically the order to fit them on the page properly, is summarize data. So these are taking a bunch or a large amount of data and summarizing it in some way to something that's a bit more manageable. There's data enrichment, and I should mention the ones with the cross are new tools at 10.9. So we have 3 new tools. So in summarize data, we had summarize, center, and dispersion. For data enrichment, we have a new tool, which is great because it used to just be one tool on its own in this tool set, and that is calculate motion statistics. For analyze patterns, that's usually some kind of statistical analysis that we're doing. Find locations, so given a bunch of data, find a few points of interest. And I unfortunately have the cross on find wall locations. It is not actually new at 10.9. Manage data, so we have data data management. So appending data, calculating new values, changing the data based on the geometry, so clipping it or dissolving, merge or overlay, and then also the copy tool, so you can copy your data around to different data stores, the relational data store, spatiotemporal if it's a feature service, or to a big data file share. And again, we will talk about data a bit more, so if those words didn't mean anything yet, that is fine. And then use proximity, again, just like data enrichment, very exciting this year that we no longer just have one tool in the tool set. We now have a new tool called trace proximity events, which was a tool that came out of kind of thinking about COVID-19 use cases, but can be applied to a bunch of different fields. So the tools in GeoAnalytics Server often work with both space and time. Time is not a requirement for most of these tools, but because, like I said earlier, with big data, often it's accumulated and there's some kind of timestamp. Often we see like tracking data or GPS data, so we try and include time when possible. So you can define your temporal input by using instance, which is just a moment in time, or intervals, which is a duration, so it has a start and end time. The most common data sets that we see for big data are usually points with an instant. You can analyze in time steps. So here I've aggregated points and we're actually looking at, I believe, lightning across the US. Might be on a weekly time step there. And then you can actually visualize those results in Pro using the time slider, as well as with Map Viewer, they have a time slider as well. So with that, Noah is going to give us our first demo of the GeoAnalytics Server tools.
All right, so to start our demos today, I'd like to show you what it looks like to just use a GeoAnalytics tool, and I want to showcase some of our spatiotemporal analysis capabilities that Sarah mentioned. So to start off, as Sarah mentioned, there's a few different places you can use GeoAnalytics tools, and one of them is the portal map viewer, which is where I am right now. So as soon as you federate a GeoAnalytics server with your ArcGIS Enterprise, you're going to see access to this GeoAnalytics Tools button, which is where all of the tools that Sarah listed earlier will show up. And so these tools work like any other feature analysis tools that you might be familiar with. So if you've used standard tools before in ArcGIS Online or Portal for ArcGIS, they're going to look very similar, actually almost the same. In a lot of cases, the only difference is the temporal analysis capabilities that are also there that Sarah just mentioned. For example, here in aggregate points, you can see the parameter to specify time steps to create the spatiotemporal aggregation that Sarah just showed in that GIF. But today I want to show you our Find Point Clusters tool. So you may be familiar with spatial clustering using dbScan or HDBScan. If you're not, that's totally okay. But basically this is a well-known spatial clustering algorithm that we've implemented in GeoAnalytics, and we've added a temporal element to it so that you can find clusters in both space and time. So I think it's a great example of how GeoAnalytics really excels with spatiotemporal data. So to show you an example of this, I have this feature service of earthquake locations. It's, let's see, not a huge data set, but for a demo, good enough, about 70,000 features. And each one has a timestamp ranging from the 1800s to present day. So pretty wide time range. And basically, I want to use our Find Point Clusters tool to see where there are clusters of earthquake activity over time. So once again, I'm just going to go to the GeoAnalytics Tools button. Find Point Clusters is in the Analyze Patterns group, so I'll click on that and go to Find Point Clusters. So because I have the earthquakes layer already in my map, I have it selected here by default. And as I mentioned before a little bit, there are two clustering methods I can choose from, dbScan and HDBScan. So I won't go into the advantages or disadvantages of these now. There's a lot of info out there if you're interested in that. But dbScan currently is the only one that supports time. So I'm going to use that for this demo now. So next I need to choose the minimum number of points that can be used to seed a cluster. So I'm going to specify 10 earthquakes as my minimum. And then dbScan traditionally has a spatial search range that's used where the algorithm will search from each point this distance to help find clusters. And so I'm going to set this to 50 miles. Now something that's new, if you're familiar with this algorithm, is the ability to specify a search duration as well. And this is what creates that temporal element of the analysis. So in addition to searching from each cluster in space, the algorithm will also search from each cluster in time. And because this is a pretty wide-ranging data set, it goes from the 1800s to current day. So I'm going to specify 1 year as my search duration so that we can find clusters of earthquakes on the scale of years rather than something more fine scale. So I'll give it a unique output name. And just like any other analysis tools that you might be used to in ArcGIS, there are environment variables, so we can specify which coordinate system we want to use, as well as the process extent and where we want to write that data out to. By default, it's going to be written to the spatiotemporal big data store, which Sarah will talk a little bit about later, I think. So now that I have that all defined, I'm going to not use the current extent and run that tool. So this job is currently being sent to my GeoAnalytics server from the portal app. And this job will be running across the cores of my single GeoAnalytics machine. If I had multiple GeoAnalytics machines, the job would be split up among the cores of those machines. And so when my analysis completes, we'll get a warning that a few of the records were invalid, probably a few null geometries or something like that. And then we'll see that our result is time enabled. That's because each feature in the result is going to be assigned a cluster ID if it was found to be within a cluster, -1 if not, and then the start time and end time of that cluster. And what that allows us to do is scan through time using the time slider and portal and see where the algorithm has discovered clusters. So we see here is a cluster activity from 1966 that the algorithm has discovered. And we can continue to search through our data. So this is really significant because it shows not just spatial trends in earthquake activity, but spatiotemporal. And so we can see that a lot of these clusters may have been present for a few years, but then dissipated. while others continue over the course of time. So this is just one example of how we've kind of tried to incorporate some novel spatiotemporal analysis into our tools. And with that, I'm going to hand it back to Sarah to talk more about our analysis capabilities.
Thank you, Noah. I'm going to talk about a few tools in detail, especially the tools that are kind of unique or most powerful. And the first one is join features. I think this is the most powerful tool. A lot of the use cases people bring up are based on some kind of join. So this is, a spatial join, a temporal join, or an attribute join. So this allows you to join data by location, time, and attributes. You can do all of that at once, one of them, two of them, whatever combination you want. It's all in one tool, and you can just choose which type of joins you want to add. Because the space-time join is something people often want, and it's kind of hidden in this tool, this example shows two examples, so A and B. For A, we are joining points instant, this first diagram here, second, to polygons that are an interval with time on the z-axis. So you can see where they intersect in both space and time, and then we end up with the polygon values. In this case, we just have the count of points that were within them. And then we do the opposite here just to show that it's possible. It is the points that we're joining to. Polygons are joining to those points. Again, you see them where they intersect, and you end up with the points with the polygon attributes on there. There are many different ways and different joins. I think the number of permutations is hundreds. So for a spatial join, you can do more than just intersect. You can do within a near distance, or you can do touches or crosses. With time, there are a whole bunch of different operations. I believe there's 10 to 15 of them. And then an attribute join, you're just matching attribute fields. Reconstruct Tracks is another tool that's very popular. If you want to learn more about track data, I would recommend looking at the ArcGIS Pro GeoAnalytics presentation. The concepts there are the same, and we go through a whole bunch of the track tools in more detail. So I would recommend checking that one out and then looking into the tools from there. But this track reconstruction uses time series location data. So, if you are a vehicle moving and you had a measurement every 5 seconds of the location and time, we would turn that from those points and turn it into the line that you've traveled. So some examples are hurricanes, ships, and airplanes. And here on the bottom right, a little known feature is you can also buffer. So normally you would turn those points into lines, but you can also buffer each point by some attribute value. So for example, we have hurricanes and we buffered it by maybe wind speed. So you get a good idea of how it's traveling, but you can use any attribute that you have available or an expression. Build multivariable grid is another tool. We do not have this one in GeoAnalytics Pro, so this is a tool unique to GeoAnalytics Server, and I think it might be really powerful for a lot of people, not even if you have huge data, but it's built to aggregate multiple data sets into one. And so you can do a whole bunch of calculations on a whole bunch of different data sets if you want. You can calculate the distance to the nearest something, and that would be the layer you give. You can find the attributes of the nearest, the summary of the intersecting, or summary within a given distance. And this is kind of hard to conceptualize sometimes, so I have a few examples. And so remember, you can do all of these calculations in one to create one layer, and each attribute or each calculation ends up being its own attribute. Oh, and I added that. One or more layers of interest. So this layer is really helpful for visualization, of course, but then also input to statistical tools like GLR or Random Forest. You just have all of these attributes in one place. You can also use it to enrich. We have another tool that you can enrich points from this grid that you've already created. So here's an example to the nearest subway station. So you end up getting these polygon layers with a distance. Here's the nearest park. Here's the population per square mile, and the number of complaints. So each of these, I have 4 here. This would be 4 attribute results. And so I would have this grid with values for each that you could then use for other tools, visualization, and enrichment. Something else that is really important is the access to use PySpark with GeoAnalytics Server. This is the one that Noah and Mike have a different presentation for, so if you're more interested in this, I would highly recommend looking and checking out that presentation. They do a lot of really cool examples, but it allows you to use the tool which we call Run Python script to run distributed analysis on your GeoAnalytics server. So in addition to all those tools we listed, you can write your own custom tool or tweak it so that you can run the analysis across your 3 servers or 1 server, whatever you have set up, and get the results that you're most interested in. So you're running that script on your GeoAnalytics server site. You can use other Python functionality and distributed analysis across your site. And then you can also pipeline GeoAnalytics tools. So the way GeoAnalytics tools work, if you were to go run a tool, is you run a tool and it creates an output. And then you could use that output as an input to another tool and run it again. But if you say you ran 5 tools in a row, just chaining them together, you would get an output every time in the middle. And with big data, that can be a lot, right? You're going to suddenly have 4 extra data sets that you don't actually need if you just wanted that end result. So the Run Python script actually allows you to chain those tools together so you only have one ultimate output. So it's faster processing as well as better for the amount of data that you're saving. And then you can use PySpark. So you're able to use the machine learning libraries and SQL libraries and data frames that are available through PySpark. So the next thing we're going to talk about is data integration. So your inputs and your outputs that we support. So what types of data can you analyze with GeoAnalytics Server and where can they come from? So you can definitely access data from your enterprise deployment. So that could be something like feature services. I mean, it's mostly feature services. And then you can also analyze data that's been collected with ArcGIS GeoAnalytics Server. And here's what's very unique about GeoAnalytics Server is you can analyze data in Hive, HDFS, and files. And those files can be shapefiles, Parquet files, ORC, delimited files. And you can connect to Azure and Amazon cloud stores. So big data file shares are something a lot of people will use with GeoAnalytics Server. It's not required, but it's one way to get in, or it's the way you can get in your delimited files, shapefiles, ORC, Parquet. So they read directly from those sources that I just mentioned. The shared folders is the one that does the shapefiles, the delimited files. And I'm ahead of myself. Those are the supported file types. So the 4 listed there. Delimited files can be CSV. It could really be any delimiter. You can customize it. You know, if you wanted your delimiter to be your name, that is fine. That is supported. But this is what it looks like. So when you are reading something in as a big data file share, and let's say we had a big data file share called extreme events, and then we had a folder called lightning. Lightning is a data set. It's represented by a folder, and then we have 12 data sets within it, 12 shapefiles. All of those are one single data set when used in GeoAnalytics. So as long as they have the same schema and then the same file type, you know, you couldn't have a CSV in there that would also be read, they will be used for analysis in GeoAnalytics. So you can also write back to big data file shares. So this was something that was highly requested. We're able to read everything in, but then often you don't just want to write your result to a feature service. You maybe want to write it to somewhere else that someone else in your organization can access. So for example, maybe you have an organization that's like, we love Azure Blob Storage. Like, I want to be able to write out CSVs to Blob Storage so someone on another team can access that and then do their workflow. You know, we're not these companies that just like do all GIS. Like, we have a lot of things going on. So how can we make the flow work? How can we interact with other teams? So we have this image that came from a blog, and we do have a blog on the data sources that are supported. So the inputs on the left, we have GIS data, so hosted feature layers, stream services, feature services, and then external storage. So Azure Blob Storage, Data Lake, Amazon S3, HDFS Hive, and then the folder, which could also be a network drive. Analysis happens on the GeoAnalytics server, and then the output results, by default, it's this top right, which is the hosted feature layers, but then also optionally, you can write back to your Azure Blob Storage or Data Lake, Amazon S3, HDFS, or your folder share. Oh, and here it is boxed. So how do you actually use those data sources? It's through Server Manager where you would go and register a big data file share, and then you'd specify the path, the name that you want to call it, and then create it. At this time, your GeoAnalytics server is going and it's looking at that data, it's making sure that it has access, and then it is querying the data source to try and figure out what is the schema. So it's going to do a best guess to figure out which fields represent time and geometry as well as the field names. And then you're able to edit and change things as needed. So at that point, you could hit edit. You would see that I've registered 45 data sets with this one big data file share, and I'm able to edit the fields, the time, geometry. There's also some more advanced options where you can look at the manifest, which is the outline of the schema. You can upload hints files. There's a whole bunch of more details in the documentation. And if you want to know more or you're really curious, like feel free to send us an email because this is something that is a real value proposition for GeoAnalytics. It's very powerful to just be able to connect to your data sources. I will mention that there's something similar now with ArcGIS Pro with big data connections. So if you came into this and you're like, I really want to connect to my collection of folders that have like CSVs or shapefiles, those are supported with big data connections. The cloud store HDFS is not, but if that's what you're interested in, you might be able to use ArcGIS Pro GeoAnalytics tools and connect to those data sources. So with that, Noah is now going to give us a demo.
All right, so Sarah just showed you how to register a big data file share and what that looks like. So I'm going to show you using a big data file share sourced from an Amazon S3 bucket and using that data set in analysis. So today I have a S3 bucket called GA Server Demo Data BDFS, and I have lots of data sets within this bucket. As you can see here, each of these folders represents a data set. Some of them could contain shapefiles, some could contain Parquet or ORC or whatever sources we support or types we support. Today, I'm just going to be using this data set with a single CSV file inside representing polygons that were discovered using machine learning in satellite imagery that represent rooftops throughout Texas. So as Sarah showed, I can register this bucket as a big data file share in the Server Manager app on my GeoAnalytics server. So before this demo, I registered the bucket as a cloud store. This just means giving it credentials to the bucket so that it can read and write. And then I selected the cloud store as a big data file share. And when I did this, GeoAnalytics discovered the 67 data sets or folders inside. And here's the one that I'm interested in. So we'll see it has two fields. One is the state name, and one is the geometry string field, which contains GeoJSON. That's the polygon data of each rooftop. Another thing to point out here is that I've selected to exclude geometry fields in analysis. And what this means is that by default, GeoAnalytics will output that string GeoJSON field in the result of it'll be carried over in any analysis. And this just prevents that so that only the true geometry field will be carried over and not the GeoJSON string itself. So this all looks good. I think I'm ready to use this data set in analysis, so I'll click Save. And just to show you, once you create a big data file share, it's available in your portal content, just like any other portal item. So here it is. Each one is prefaced with this big data file shares in the name, so they're easy to find, and it's also a unique type as well. So I could use this in the portal map viewer or ArcGIS Pro if I'm signed into this enterprise. But today I'm going to use a hosted notebook on my notebook server to run the analysis and show you what I can do with this. So in the notebook, I'm going to be using the ArcGIS API for Python. So I'm going to connect to my GIS with the API. Then I'm also going to set these environment variables. I have verbose set to true, which is nice because it allows GeoAnalytics Tools to return some really useful messages. And then I also have the spatial reference set for all the analysis that I'm going to be doing. So because the big data file share is treated like any other portal item, I can search for it in my contents pane and add it into this notebook. And then if I return the result, we'll see it's a list of all the data sets inside. So I'm going to find the one that I'm interested in, the rooftop polygons, and there it is. So just to reiterate, this data is never being copied up to ArcGIS Enterprise. It's not living in GeoAnalytics Server. It's always going to be living in that S3 bucket that we registered and only being read once you run a tool. And so to verify that I've registered this data set correctly and that it's being read by GeoAnalytics as I would expect, I'm going to use this tool called Describe Dataset, which just kind of runs through the features in the dataset, summarizes them, and returns a summary. So if I submit this job now, just as we saw with that fine point clusters job, this is going to be sent to my GeoAnalytics server over REST, and it'll break up the job of reading that data into distributed tasks. So to show you a little bit more background, Apache Spark is the engine that kind of drives GeoAnalytics under the hood. And if you're familiar with Spark, you might be interested in what it's doing. So if you go to the GeoAnalytics Server Admin API, you can actually see that. This is a health report from Spark, which shows that 6 cores are being used currently in this job and about 51 gigs of RAM. It shows that I only have one worker. That's because I have one GeoAnalytics server right now. If I had more servers, they would each show up as their own worker with cores and memory used on each. So if this is pretty alien to you, you don't have to worry about it. It's kind of a peek under the hood, but it just shows that this analysis is being completed using Spark on my GeoAnalytics server. So it looks like the job is finishing up. Once it's finished, we can query the result, see what it looks like. We'll see that it returned the count of features that are valid, and it looks like we have a little under 10 million polygons in this data set. So now that I want to, well, I know that I'm able to read the data. I know the count of features that I'm working with. And so I'm going to dive in and try to run some analysis on this now. What my goal is to find all polygons that are within a near distance to rivers in the US. So I've loaded in this other data set that I have in my big data file share, which has polylines representing all of the rivers in North America. We need to give this a unique name, and I'm also going to run describe on it just to show how many features are in it and what the fields look like in the data set. So when my goal is to run the join features tool, where my target layer is going to be the rooftop polygons, and I'm going to join my river polylines to the rooftops wherever the two are within 1,000 feet of each other. Something else to note is that I'm going to specify the data store in this job so that it's going to write not out to a feature service, but I'm going to write back to a big data file share. So in this case, I have a big data file share called testing data out IAM, and I'm going to write back to that big data file share using Parquet. And so this is kind of just scratching the surface of what you can do in terms of writing out your data to big data file shares. But it shows that we're not limited to just writing back out to feature services. We can write back to most of the sources that we support. So I ran this job a little bit earlier. As you can see, we're joining 400,000 rivers to about 10 million rooftop polygons. And to avoid making you watch 14 minutes of this job running, I did it before. But you'll see says the results were written back out to that file share. And if we go back up to our S3 bucket, here is the data itself. So GeoAnalytics has written this as multiple Parquet files, and it is now available for me to use in GeoAnalytics as a big data file share, or with third-party applications just as a standard Parquet dataset. So I hope this gave you a good example of how to get your data into GeoAnalytics and what you can do with it, and also kind of the spatial analytics that we kind of focus on and specialize in, and how easy it is to use those either programmatically with the notebook or in the portal map viewer. So I'm going to hand it back to Sarah to talk about GeoAnalytics deployment and to wrap things up.
Thank you, Noah. Now we're going to talk about how you can actually deploy GeoAnalytics Server. So what do you need to install to use ArcGIS GeoAnalytics Server? We have Portal for ArcGIS, ArcGIS Server, ArcGIS Web Adapter, and ArcGIS Data Store. If you already have a base deployment, you've already installed all of these components. To actually get GeoAnalytics Server, you're just going to reinstall some components on additional machines. So GeoAnalytics Server sites can be 1 or 3 machines. So you can either have a deployment like this. You can see we have the base deployment on the left, and then we have a single machine on our GeoAnalytics Server site with the web adapter, and then a single ArcGIS data store with a spatiotemporal site. The other option is a 3-machine site. So you have your base deployment, you have 3 machines on your GeoAnalytics Server site, and then 3 machines on your spatiotemporal site. So to actually configure it, let's look at this 3-machine example. The first step is to set up your base deployment. So if you already have this, you are done that first step. You can use Enterprise Builder, you can use Cloud Builder, you can use templates on Amazon and Azure, whatever you're using to set up your base deployment. Now to actually do GeoAnalytics Server, here's the actual extra steps. So that first step is just what you would need to have Enterprise anyways. So now to set up GeoAnalytics Server, you're installing ArcGIS Server. So it's the same install you would have done for your hosting server or for any other server. What's different here is you license it as a GeoAnalytics server instead of a GIS server license. So the only difference is when you browse to that license file, you choose the GeoAnalytics server one. You then set up a web adapter just as you did with the hosting server, and you federate it with your portal. The next part is you can install your ArcGIS data store. When you do this, you're going to configure it as a spatiotemporal data store instead of a relational or tile cache, and you're configuring it with your hosting server. For the ArcGIS data store, you're always configuring it with a hosting server. It hosts the data. So at this point, you pretty much have everything set up. You just need to say, hey, this server that I just registered, it's special, it's my GeoAnalytics server. And to show that, I have a GIF. Oops, and we're going to have to loop to the front, I think. So in your organization page, you go to Settings. You're going to click the server role. Here we go. So you're going to go to Settings. You go to Servers. You scroll down to the server that you federated, and there's this new button that says Configure Server Role. This UI used to look a bit different. It's been updated so that it's much more functional. You then choose GeoAnalytics Server and just toggle it on and hit Save. So right now it's saying to the portal, hey, this new server, this is the GeoAnalytics server, and soon you'll see this window close and it will say GeoAnalytics for the server role for this server. So that's all you have to do to get the GeoAnalytics server set up. So let's talk about the system requirements for the machines that you're going to use for GeoAnalytics Server. So for the base ArcGIS Enterprise deployment, these are different specs. These are for the Enterprise deployment. They are available for documentation, but the minimum is 4 cores and 16 gigs of RAM. For the spatiotemporal data store, the minimum is 16 gigs of RAM for each machine, but we definitely recommend 32 if possible. It also has to have fast and sufficient disk space for data because this is where you're storing all of the data for your feature services. We do recommend the same number of machines as your GeoAnalytics server or more. So if you have 1 GeoAnalytics server, you should have at least 1 spatiotemporal data store. If you have 3 GeoAnalytics servers or machines in the site, you should have at least 3 spatiotemporal data stores. Then the specs for the ArcGIS GeoAnalytics server, you have a minimum of 4 cores with 16 gigs of RAM for each machine. And then you also need sufficient temp space for compute. So if you run out of memory. So GeoAnalytics uses Spark to process, which uses in-memory computation. If you run out of memory, then you are going to have it spill over to disk. So you want some temp space to be able to spill over if needed. For the actual deployment, it's compatible with both Windows and Linux, so it doesn't matter which one, and it can be deployed on premises or in the cloud, so Azure and Amazon. We strongly recommend you simplify the deployment of ArcGIS Enterprise. Do not make it more complicated for yourself. There's many ways to simplify it. I mentioned a few of them. So for the base deployment, you should use ArcGIS Enterprise Builder if you can. You can use Chef cookbooks for ArcGIS. This is really helpful for multi-machine deployments and HA deployments. Or you can also use the ArcGIS Enterprise Cloud Builder for AWS and Azure and the templates they have available there. So in summary, we are done the deployments. In summary of this whole presentation, GeoAnalytics is integrated. It works with your existing big data storage and or your existing GIS data or what you currently use in desktop and enterprise. It's spatiotemporal, so these tools are designed to analyze data in both space and time. And it's accelerated. It's meant to speed up analytical processing time using built-in parallel compute. And lastly, it's actionable. So it's fast, but then it also gives you answers that you're interested in looking into. You're able to crunch through large volumes of data to generate actionable insights and intelligence. This enables you and your organization to visualize and react to large amounts of data in a clearer and more meaningful way. So I have a few helpful links here. We will try and provide these as well. Oh, and then sorry, I meant to say, I've mentioned a few times, I think, that if you have any questions, you can contact us. This is our email at the bottom for the team. So geoanalytics-PEs for product engineers at esri.com. We really appreciate hearing from you, hearing what you're trying to do and what problems you're running into. Help us better the product. So figuring out new tools or parameters or anything that we can do to improve the experience for you. And with that, we'd like to thank you so much. If you have the time, please provide your feedback for this session. You can get the survey directly below this video, and we really appreciate that too. We do read through all of it. We listen to see if there's something missing in the presentation, or if you want us to go into more detail, we appreciate all of that feedback. So thank you so much.